We're now going to cover the singleton pattern. In this discussion, you'll not only understand how the singleton pattern works in general, but you'll also learn to recognize how this pattern can be applied to centralize access to global variables. The purpose of applying the singleton pattern is to simplify access to global resources without requiring the use of global variables. Please note, however, that the singleton pattern has a number of very well-known drawbacks, so apply it with care. We'll talk about a lot of those drawbacks throughout the discussion. But first, let's discuss what the context might be for why you'd even consider applying this pattern to the expression tree processing app in the first place. It turns out that in certain cases, we only need a single instance of particular objects. For example, we only really need to keep track of one set of command line options to use to determine the operating mode and other operations. Likewise, there's only one dispatcher that we use to drive the expression tree input handling. And there's also only one platform-specific strategy that we use to keep track of various capabilities for I/O and other platform-centric operations. Now, we could certainly pass these objects as parameters to all the different parts of the program, but that would become very tedious and cluttered, so we'd like to look for some alternative approaches. One approach is to define global variables, which you can do in Java by creating a public class and defining a number of public static data members in that class. There's a number of problems with using global variables, however. The deepest problem is it increases implicit dependencies and can reduce program clarity in certain cases because globals don't necessarily respect scope so that they're accessible almost everywhere in the program, and it makes it difficult to systematically reuse different parts of the program because they have to carry along those global dependencies with them. There's also some other downsides with using global variables. You end up incurring time and space overhead even if they're not actually used because they have to be created when the program starts. It's also hard to extend global variables transparently. You have to go and modify the code. And in certain programming languages and runtime environments, initializing and destroying global variables is very tricky. This is particularly problematic in C++. The discussion we're about to have here won't address all of these liabilities with global variables, just some of them. So what's our solution? We're going to centralize access to global resources so we can have a single point of access to those resources without requiring the use of one or more global variables. Let's take a quick look at how we might actually use this in our solution. We're going to focus here on the command line version, but be aware you could use it in other GUI versions as well, and we'll show that when we look at the code. In this particular case, we're looking at the main program, and as you can see, when it first starts to run, it uses an options singleton to allocate the object for keeping track of the options on demand. Then we go ahead and parse the command line options and set any internal flags that keep track of what mode we're running in and other things that are related to command line option input. We then go ahead and create the appropriate input handler based on the command line options, whether it's verbose mode, succinct mode, whatnot. And in this case, once again, we have an instance method that we use to access the one and only input dispatcher. And once that's done being created, we then go ahead and run the main event loop, which dispatches all the input using the input dispatcher, using callbacks and our template method pattern we looked at in the previous lesson. This particular way of arranging the solution is given a name in the Gang of Four book. It's called the singleton pattern. The intent of this pattern is to ensure a class has only one instance and to provide a global point of access to that instance. You should consider applying this pattern in a couple of cases. First, when there has to be exactly one instance of a class and it needs to be accessible from a well-known access point. And you could also consider applying this when this sole instance should be extensible via subclassing, and clients should be able to use the extended instance without modifying their code in any way. Let's take a look at the structure and participants in this pattern. This is probably by far the simplest pattern in the Gang of Four book. It's also by far the most notorious pattern, as we'll see shortly. The way it's implemented is very straightforward. You create a class that has its constructor in private or protected section, so you can't end up creating instances of it. And the only way to get access to it is to make an invocation on a static method called instance. And this static method turns around and checks a static data member, which is the unique instance, which could be a pointer or a reference. And it checks to see whether this is null or not. And if it's null, it turns around and creates a new instance. And in either case, whether it was previously null or it is not previously null, you return the unique instance as the result of the instance method. In our expression tree processing application, we implement the options class this way, the platform class this way, and the input dispatcher this way, just to illustrate how you can use singleton. Let's take a look at how we could actually implement something in Java to use the singleton pattern. This particular example uses the model we just talked about before. We have a private constructor to prevent multiple instantiations of this. We go ahead and hold the one and only instance in a static data member that's private. And then we go ahead and define the instance method, which is used to check to see if instance has already been allocated. And if it has not been allocated, we allocate it. And in either case, we return back the pointer or the reference to the actual allocated instance. There's also a number of accessor methods that we can have to check for various enabled options that were created when we created the options singleton. We're now going to go ahead and take a look at a couple of different uses of singleton in our solution so you get a better feeling about how to implement it and some of the variations you can use when you implement it. We implement the singleton pattern in several places in our expression tree processing app. Let's take a look at a couple of the most interesting ones now. If we take a look at the main.java file, this is what contains the main class and the main method for the command line version of the application. There's a couple of uses of singleton here that are worth noting. The first one is how we use singleton in order to be able to parse any command line arguments that are passed in order to determine whether the user wants verbose mode or succinct mode. Let's go take a look and see how options is implemented as a singleton. Here's the options class. This implements the classic singleton implementation from the Gang of Four book. This implementation is not thread safe. We'll talk later in this lesson about how to enhance singletons to make them thread safe. We put the constructor in the private part. We indicate it's private. We go ahead and do that so that we'll only have one instance. We then define ourselves a private static options data member called unique instance. And we define an instance static method that checks to see if unique instance is null, and if so, it allocates the one and only singleton instance, and then it goes ahead and returns the reference in either case. We also define an accessor method called verbose, which is used to check whether or not we're enabled with verbose mode or not. And here's the parseargs method that's used to check the command line that's passed in from the user to see whether or not the user wants verbose mode. Going back to the main program, you can see once we've determined that we have verbose mode or not by calling parseargs and initializing the singleton the first time in on demand. We can then check to see whether or not verbose mode is set, and then we'll go ahead and print output. Notice, by the way, that we're printing the output using the platform singleton, and we use the platform singleton in order to return the strategy that handles the difference between output on the Android platform or output on the command line platform. Down here is another example of singleton. This time we use it for the input dispatcher. We're going to talk about input dispatcher to illustrate yet again how to use the singleton pattern, which is pretty much identical to the way we did it for options, but also because it's worth understanding how we use the input dispatcher to drive the main event loop that's used both for the command line version as well as for the Android version. The first thing that happens when input dispatcher's instance method is called is it basically does what we did before. Input dispatcher is also implemented as a singleton. Its constructor is made private. We have a private static input dispatcher unique instance, just like we did for the options singleton. And we implement the instance method to allocate this on demand. There's a number of interesting methods here, one of which is called make handler. And we pass make handler various flags, whether we're running in verbose mode, the input and output objects that are used to read and write to whatever platform we happen to be running on. And this turns around and delegates down to the underlying input handler factory method make handler, which makes either a succinct mode handler or a verbose mode handler. There's also a couple other methods I want to call your attention to. These are the methods that are used to dispatch input events. If we're running in the command line version, there's a method called dispatch all inputs, which continuously runs while the input dispatching done flag is false, calling the handle input template method on the input handler instance that we created by that factory. As you saw in the template method video, handle input is the template method that's then used to direct the algorithm for carrying out the various succinct or verbose mode operating modes. For the Android versions, we don't actually run an event loop. We wait until users click buttons to enter the results of expressions they've entered visually using the graphical user interface. In this particular case, we only dispatch one event at a time, which simply turns around and forwards to the input handler's handle input template method. We'll see how that gets called in just a minute. Down here towards the bottom, we have a helper method called end_input_dispatching, which sets the input_dispatching_done method to true. This particular method is actually called from the quit handler. If you take a look at the quit command extends user command, and when its execute method is called, it simply turns around and tells the input dispatcher to shut down. Quit commands are generated under a couple of circumstances. One is if you actually type in quit to the command line, and another is if you give the wrong input to certain parts of the program. For example, if you try to create the wrong kind of traversal strategy, you'll end up getting back a quit handler. Or if you type in the wrong kind of command, you'll get back a quit handler, which can be used to shut things down. It's worth noting that we could have avoided the use of a singleton here by passing in an instance of a non-singleton input dispatcher and stored this internally to the quit command. And while that is certainly plausible, when you start trying to do that through many layers of software, you can end up passing around a lot of parameters, which makes your code rather cluttered looking. So sometimes, arguably, singleton can help to reduce the clutter. But you have to be careful because it has other liabilities as well. So that's the main use of this particular set of singletons in the context of the command line version of the program. Let's go take a quick look at one of the GUI versions that we have for Android. This is the one that runs the succinct mode in Android for GUI processing. In this case, this is implemented as an Android activity, and that means it has an onCreate method that gets called when the activity is started. And as you can see here, we go ahead and create our options singleton here. We also create our platform singleton here. And then when a user enters in the expression via the GUI and clicks the enter button, you can see what happens here. When the enter button is clicked, that turns around and makes a succinct mode handler and then dispatches one input event using the input dispatcher singleton to dispatch one input event at a time, because this is not actually running in the same event loop that we have for the command line version. So this illustrates how we apply the singleton pattern in the context of our expression tree processing app. As we talked about, and we will continue to talk about through the rest of this lesson, there are pros and cons with singleton, so you need to think carefully about whether it's right for you. This is just an illustration of how it could be applied if you decide to use it for your program. Let's go ahead and talk about the consequences of applying this pattern. There's a number of benefits to using singleton. It can help to declutter class and method interfaces because you don't have to pass around all these objects as parameters everywhere. It helps to reduce namespace pollution and centralizes access to global resources because rather than having global variables, you end up having singletons, which are scoped a bit better. You can have extension by subclassing. You can subclass a singleton, especially if you make its constructor protected, and then you can plug and play the new instances via various means. You only end up allocating resources for objects that are actually accessed at least once because they're created on demand the first time you call instance. And it also helps to alleviate problems with global variables in certain programming languages. This is particularly an issue in C++, not really an issue in Java. There are, of course, a number of significant downsides. First and foremost, singleton does not address all of the liabilities with global variables. In particular, it still has all those implicit dependencies and reduced programming clarity that comes from using globals. So you should be very careful before you choose to use this pattern. Another issue may be that the implementation could be less efficient than a global variable because there's a little bit of more indirection, and you may also have some additional overhead for synchronization, which we'll talk about in a minute. Speaking of synchronization, there's a number of very subtle and pernicious concurrency and dynamic loading traps and pitfalls you have to be wary of when you implement this pattern. As I mentioned before, this is a very infamous pattern. There's a number of websites that go into great detail of the evilness of singleton. So take a look at those if you want to understand some of the drawbacks. I use singleton in practice very sparingly. There are some situations where it makes sense, and we'll talk about those in a second. Let's talk about how you would actually implement this pattern if you think you might want to use it. The first thing you should do if you want to implement the pattern is determine if you really need to use it. There's a number of good places to go to find discussions of when you should use it and when not to use it. Here's a couple of criteria that you might want to consider when deciding to use it. Will every application use the class in exactly the same way? Exactly is the key word here. Will every application ever need only one instance of this class? Ever and one are the key words. And should the clients of this class be unaware of the application that they are part of? If you can answer unequivocally yes to all those things, then singleton may be for you. But it's still often possible and often desirable to avoid using it in your program. If you choose to implement it, here's typically what you have to do. you define a static instance method and data. So as you can see here, we have a class called Singleton. We have a static method that we use called instance that's used to allocate this, and then we go ahead and create a static data member that's actually going to be used to keep track of the value of the singleton. And if that starts out as null, then we turn around and allocate a new instance. There's a number of subtle concurrency hazards we have to think about if we end up using our singleton in a concurrent context. If you're not using concurrency, then what I'm about to talk about is overkill. But you never quite know whether you'll be taking some code that runs in a single-threaded environment and trying to port it to a multi-threaded concurrent environment. So some of what I'm about to talk about is just good practice to be aware of. The main problem you have with singleton in the context of synchronization and threading is that the default implementation described in the Gang of Four book has too little synchronization. So as a result, if multiple threads of control show up simultaneously, they may all find the unique instance to be null, in which case they're all going to go ahead and allocate that instance, which results in all kinds of confusion. One way to solve this problem is to synchronize the creation and access to the singleton instance. So you could put a synchronized block into all the code that checks to see whether the singleton has been initialized yet or not. The downside with this is really too much synchronization. You'll end up incurring a locking overhead every time you access the value of the singleton, which is wildly more inefficient in a multi-threaded environment than using a global variable, and it may discourage people from trying to move away from globals as a result. There's a couple of different ways to solve this problem. One is to take advantage of some Java features that are relatively recent that provide just the right amount of synchronization. And to do that, you put the keyword volatile in front of the singleton instance. And then you change the code just a little bit. And what happens here is we end up just synchronizing the first time in. We only end up synchronizing when instance is null, and if instance is not null, then we can go ahead and return the initialized instance. No synchronization is required after you've created it the first time. Keep in mind, however, that this solution only works for JDK 5 and above. This was added specifically to the Java memory model as the result of a long series of discussions that took place based on a pattern I actually wrote for the POSA 2 book, Pattern-Oriented Software Architecture Volume 2 book, called Double Check Locking. And if you take a look at this link, you'll find out all kinds of information about the discussions that were generated because of the double check locking optimization and finding ways to make it work in Java. An alternative approach, which is actually arguably more portable and somewhat easier to understand, is shown on this slide. This particular approach is another way of defining singleton, and what it does is it takes advantage of certain properties of class loading in Java and how that's made to be thread safe and atomic and so on. And so this is a way of being able to do singleton that has many of the same benefits of what we saw before, except it'll run in all versions of the Java development kit. There's a nice article at Wikipedia that talks about this solution. This solution is courtesy of Bill Pugh, who's a professor at the University of Maryland, who has lots of expertise in memory models and concurrency and synchronization. There's also some other implementation considerations. How do you delete singletons? Ironically, the original Gang of Four book description of singleton talks about creating the singleton, but nothing about deleting it. To overcome that gap in the creational pattern space, John Vlasides came back and wrote an article in C++ Report magazine that also appeared in his pattern hatching book, which describes how to delete singletons. And that is another good place to look for some ideas about how to delete singletons. One other way to be able to deal with this is to create some kind of singleton manager in order to make sure that all the singletons reside in one centrally managed location so that when you have to delete them and make them go away, there's a single place to go to remove them. There's a paper you can take a look at my website that talks about how we did this for some of our C++ middleware work, where global variable construction is very tricky and problematic in a portable way. Singleton is used in a surprisingly large number of places, perhaps misused, people would argue, in a surprisingly large number of cases. An interesting case I talked about recently with some folks who work on Java is their thread pool mechanism for multi-core. There's only one set of cores on a multi-core machine, and so they use singleton internally to their multi-core software implementation in order to be able to manage access to that single group of cores. We actually provided an implementation in some of our software in C++ that bakes in support for proper singleton synchronization into the implementation as a parameterized type. And I encourage you to take a look at the Wikipedia article on double check locking for lots and lots more information about how to use singleton properly in a multi-threaded environment. So to wrap up this discussion, singleton is used to simplify access to global resources in our expression tree processing app. I primarily used singleton just to illustrate how the pattern worked. It certainly would have been possible to rewrite the application to not use singleton, arguably that might have been a better thing to do. To some extent, Singleton is the go-to of patterns. In other words, it's a capability that is widely maligned. So apply it with care, and if you really need it, it can be helpful, but there's almost always better ways of being able to apply and solve the problems that Singleton is trying to address.